Okay. All right. Hi, everybody. Welcome to the Storage API Sync for Subspace Labs. Today, we're going to be talking about our progress on archiving Kusama through our Relayer application. We're very close to having this working on our testnet. So, Serge, if you would like to start off, since you're kind of leading this project, and give us an update on what you've been working on since yesterday.
Sure. Let me share. Okay, so I've been working on the resync of the old blocks recently on restart of Relayer. And yeah, we also moved Relayer code base to the other repository. So now it's together with UI, Relayer UI. And yeah, let's review the recent changes that were merged. And also today, so this is the first PR I will show you, but I also have submitted another one just now because there were some breaking changes. And so the second one is quick fixes. So yeah, in the original PR, what we have now is in the index file. So as previously, we have an array of sources, which is, let me show you more. Yeah, source chains. In this case, we only have Kusama. So it's an array of, in this case, one item. So for each one, we start with resyncing old blocks. And we call this resync blocks method, which returns an observable of blocks, and we subscribe for it. And on every new block, we send a block transaction. And after we process all blocks, after this observable is completed, we start subscribing to new blocks, same as we did before. And we do the same. We call the method for subscribing to new blocks, which returns observable of blocks. We subscribe to this observable, and for every item, we send block transaction. So currently, this is a little bit coupled, and Nazar pointed out that there must be a situation where we miss blocks when we finish resyncing blocks and before we start subscribing to new blocks. So we discussed that it will be better to decouple this and make those parallel processes. And I was thinking about that we should start with subscription to new blocks, and we store the block number of the first block, which is a new block. And then we start processing old blocks from the last process block to this saved new block number. So we have a range of missing blocks, and we process new blocks in parallel. So we start with the new blocks, and in parallel, we also process this range of old blocks. So in that case, we shouldn't have any blocks missing. I hope that is not very confusing to you. And yeah, so let's get back to the PR. I will show you what was added. So
Serge, that's just the plan going forward. That hasn't been implemented yet, this decoupling.
Yes, I will be working on this next after I finish working on the APR for this disk storage. And this is something I want to discuss with you today as well, because I have some things to clarify.
Okay, and I think
the approach is suggesting parallel. It will actually write blocks out of order. Is that correct?
Right.
Probably
could.
yes. Yes, it will write blocks. Yeah, the order won't be maintained.
Okay, so we need to make it such that it will maintain order.
Okay, I will have to think about it more in that case.
I think you just need to keep a pointer or some, not a pointer, sorry. You need to keep some sort of a reference to what is the next block you're expecting. And then as these blocks, and then put these blocks into the new blocks into a queue, whether they're coming from the resync or the new blocks that are received. And then if that block matches the next block expected by height, then you could submit it as a transaction. But otherwise, it's just going to fill the buffer. Then once there's no new blocks, then you can like check the buffer to see.
But buffer can also go too big and it will run out of memory, so it needs to be limited. It's like a little bit tricky.
Yeah. So okay, I will think about this again if we need to maintain order. Yeah, so this is currently how we handle this. So we have resync blocks method, and we use expand operator from RxJS, and we check what is the last process block number, which we get from our local storage, local state, and we add 1, so we know which one is the next block number, and then we calculate difference from finalized block over here. Yeah, we get the finalized block number, and we calculate the difference, the amount of missing blocks, and yeah, we keep processing them until the difference is 0. So in this case, if it is 0 here, we return undefined, and the observable should be, this observable for resyncing blocks should be completed, but at that stage it might happen that the new finalized block will appear. So this is a problem we have to tackle, I have to tackle. And yeah, another change was in the state class. So previously we had in the repository, we committed this JSON files for feeds for last process block, and now we don't have it in the Git. We just created on demand. So I created this method. So we just read file. It can be a file for feeds or last process block. And if there is no such file, we just create a new object and return this object. And yeah, in that case, we will just create those on demand, and we don't need to store them in GitHub. Yeah, any questions on this?
Can you say one more time the problem with the last finalized block? I didn't quite understand that.
Let me show you an example. You can see my editor, right?
Mm-hmm.
Yeah, so here on the left, you can see there is a state folder with feeds.json file. And since this file will be upgraded all the time, there is no need to keep it in our repository. So previously, I just committed the empty file with like this, with an empty object. And instead of storing this empty object file on GitHub, we just create this file on demand. Is it
from the chain state, from the blockchain itself?
Yeah.
Got it. Okay.
Feeds and last process block. So it's just like more cleaner repository.
But is that from local storage on the relay, or is that from the blockchain state?
It's when we process new block, for example, we keep the block number in this JSON file. So when we restart, we know what was the last process block. And
Okay,
same
so
for feeds. Every time we create a new feed, we store it in a record. Like this address has this feed associated. So we don't have to create feeds every time we restart Relay. It's just like optimization.
Okay. But this is local storage, not read
Yes.
from the blockchain. Okay.
Yes. Okay. So yeah, and this is a fix I mentioned earlier. Let me show you. Yeah, so previously I removed this error. So in the original implementation, we were throwing an error to complete observable, and I removed it here in the previous PR, and we used take while operator, but this is not exactly how it works. I have to check more with observable documentation. So take while just completed everything, shut down everything, and we don't process the actual old blocks. So this implementation works, but this is not very elegant. So yeah, but since I don't want relayer to be broken in the main and it might block Leo, so I currently submit this quick fix, and I will tackle this issue when I will work on decoupling. Yeah, and in the state class, there was a problem that if we remove these files, we cannot have an empty folder because Git doesn't allow you to have empty folder. So we have to check if the folder, this state folder exists, this one. And if it doesn't, we create folder first, and then we add all those JSON files.
Well, ideally, you wouldn't store anything in the repository itself. It should be like a parameter that you specify where you want to store it. A good example is when you're running it in the container. The good practice is to have a container that is that has read-only file system. So just mount something to it. Unless you mount it, it shouldn't even run.
But if we don't create this folder, it will break.
Right. I'm just saying that this folder should not be by default in the repository itself, I think.
So it's not in the repository. If we
it's not checked out, but it's like in the same folder as repository, right?
Right. No, you can specify path.
Okay.
Yeah. So this class accepts the folder string as dependency. So
Okay.
in this case, in our case, it's called state, but can be anything. Yeah, and if it doesn't exist, we have to create it. Otherwise, this will break. Any questions on this one?
I think Lou wanted to say something. He was muted.
Still muted.
You're muted, Lou.
Oh, sorry, I mute myself again. Sorry. Actually, I just want to say that Gates allows you to keep an empty folder. What you need to do is to put it like an hidden file, and it's like a .git keep, like that is a typical way.
Yeah, I know about that, but it's more like a workaround. So, and
Yeah.
it's a minor thing. So,
I have a question that is more about the background of palette phase. It
sure.
but it can be related, I think. My question is, from what I see, we don't care who submits the data. We note the feed ID on chain. And what's the meaning? What's the use case of we kept the feed ID? And we note a storage map. The key is the feed ID and the value is the metadata. I'm not sure. I don't quite understand what is this design. What the design is for.
So currently we do not restrict any, like, so basically any account can create the feed. But I think it was on the roadmap to add for each feed to add like a list of accounts that can actually submit data to those feeds. Am I right?
Yeah, that's correct.
Yeah. So, and for metadata, yeah, we store metadata. It's for mostly for UI. It's an arbitrary data. So in this case, in processing Kusama blocks, we store like block number, block hash, maybe something else. And yeah, for other use cases, it can be other data.
Okay. So, and I see the further optimization for the pellets, for the pellet feeds is to we can impose some limit on the length of the bytes, like the metadata bytes, like the data bytes. I haven't seen any like length limits on them right now.
Yeah,
So
we don't have it now. Yeah.
I think it will be a part of cost of storage mechanics. So depending on how much bytes you want to submit, you'll have to pay for it. And that will be like the natural limit. And also another limit will be just transaction and block size. You cannot submit more than that.
Yeah. Even it's only makes sense for the like block size limits. We should add a limit in the transaction itself.
Yeah, this is
Yeah, that's
something
actually on the roadmap. We've actually got a ticket for that right now. It's just not, we're trying to get the whole system working in like this honest, happy path first, and then we're going to start coming in and dealing with all of the, you know, vulnerabilities and potential security issues and trust issues that we have.
right.
Okay.
Any other questions? Liu-Cheng, do you have any other questions?
Nope.
Okay, so should we discuss the API next?
Sure.
Okay, so okay. Yeah, so I have created this class called disk. I don't know if it's a good name since we are not using the actual like file storage at the moment. Instead, Nazar is using RocksDB, but for now it's just disk. So the first question was, are we going to use it like one instance per chain, or we have one instance for everything? It's more like about the size of the chains we are trying to back up.
it's currently designed to be one per chain. Like any substrate chain, you basically point it to some API RPC, JSON RPC endpoint, and it will try
Okay.
to pull all of the blocks starting from 0. So it can be
So-
Kusama, it can be Polkadot, can be something different.
Okay, so then we need a chain name.
When you say chain, do you
And,
mean source chain, or would a pair chain
Yes.
be a chain as well?
Yes, source chain. Source chain.
Well, both of them are source chains.
Yeah, we have like a distinction here. I mean, in relayer context, we have a source, which is a relay chain. Maybe I should rename it. We have a source, which is a relay chain, and parent chain is a parent chain. So we first process blocks from the relay chain, and then we go and fetch relevant blocks from included blocks from the parent chains. But I think I understood. We need to specify a chain name here anyway. And yeah, so previously we were discussing that we might submit blocks, the old blocks, either as a batch of single block transactions, or we can potentially include multiple blocks into one transaction. So can we make some decision now maybe? Or this is something we should think more?
I think the simplest is just to do one block per transaction, since we don't have the multi-put yet, and that will be equivalent. I mean, you might save a little bit of storage overhead or a little bit of transaction fee, but it should be pretty much a very, very similar and probably work for now.
So then we need to add this a palette. I think it's palette utility for sending batch transactions. Right?
I think
What
it
does
would be
it have to
nice to
do?
have it either way. Seems useful.
I mean, it's nice to have, but it's not strictly necessary. We could just submit one transaction per block and just load up the block, like per source chain block, and just load up the target chain with as many transactions as we can fit in its block.
Yeah, we can do that, but I thought we want, yeah, I mean, that's optimization. If we don't want it now, we can do it later.
Yeah, I mean, the more palettes we bring in, the more dependencies we bring in, the more complicated we make this. Like, we're just trying to get a version 1. It doesn't have to be perfect right now.
Okay. Liu-Cheng, did you have a comment on when I mentioned palette utility?
So we want a batch transaction, right?
We discussed it before, yeah. So, because it will make like cheaper transactions, right?
Since the substrate palette utility already exists, why don't you use it directly?
Sorry, could you repeat?
Hey, Liu-Cheng, it seems like you're freezing up a lot. Maybe if you just go to audio only, it would be better for the sound quality.
Can you hear us, Liu-Cheng?
Can you hear us? I guess not.
Should we move on with the API for now, and then maybe if
Sure, we'll come back.
connection will be better. Yeah.
Yeah.
So, like the dumbest implementation I can think of is just saving like single block and getting single block, but maybe we should consider also like extracting multiple blocks like in one go, and then we just send the process like them one by one, if that would be reasonable.
I don't think you need to save a block here. You'll just read it when you've started for the first time to read everything that's stored there. And then you just continue, don't need to update it anymore.
So we run this tool script separately, right?
Yes,
For,
you just
like,
run it, you prepare a folder. That folder will contain a database with some number of blocks. You will just pull all of those blocks and continue with real network.
so we just need get block in that case.
Yeah, I think so.
Well, that's
Yeah,
actually a good point, Nazar. Maybe we should consider that because if we have to restart the relayer or like reboot the chain, then we also have to update all of these files, these databases. So it would be cleaner if we could just save these in real time. The relayer could handle it itself. And then on a restart, we're already like 99% up to the head of the chain. If we need to hard reboot the chain, like from Genesis.
You can run the script. It will like extend the database, interrupt it at any point. I just don't see why we need to write the same like the same functionality twice.
So
Once in the other script.
So the script will update from the last save blocked in the database when you rerun it, not from
Yes.
Genesis.
Yes.
Okay.
So I just imagine that this database, it will be distributed like a pre-made bundle, maybe using torrent or some download link, and you would just update the snapshot from time to time. You wouldn't like update it in real time all the time. Like if you have just 1 week worth of blocks, it will take maybe a few minutes to catch up. Doesn't really make a lot of savings for you.
Okay. That makes sense. So it probably is better just to have get block and not worry about saving it. Just treat it as read only from the point of view of the relayer.
Okay, so I guess this is all I have for now, and yeah, I guess I will continue on this API with Nazar in private. And yeah, Liu-Cheng, are you back? Can you hear us?
Yeah.
So you were saying something about Powet utilities and batching transactions.
I just want to say from my experience, the batch transaction is easy to use, and so if you want, you can use it like right now. So I'm not sure what is the difficulty.
So we considered batching just for optimization purposes, because quite often, like for example, for creating feeds, it might be useful to use batch of transactions. And if we want to submit multiple blocks, it might be also useful to use batch of transactions so like sender can save on fees.
So the batch transaction already exists in Substrate.
In Substrate by default, no. I think you need to add
we just need like add the palette utility palette into our runtime. Yeah.
Right. So currently in Subspace we don't have this palette. So we were discussing, do we actually need it? Maybe what's like in your experience, what's the trade-offs? Should we consider adding this palette?
I think we should. It is a very useful tool for the in like ecosystem, many users rely on the batch call of Pellet utility.
Okay.
Well, what is our batch size limit?
We don't calculate size at the moment, but
Right.
yeah, I will just add this to the board so we have it. We can work on this in the future. Obviously, it's not critical right now.
Okay.
Okay. Thank you, Liu-Cheng. Any questions for me?
Oh, sorry, I didn't realize you were done. Yeah, so you said there was another PR that you have submitted, or that's in progress?
I showed you. Yeah, I showed you both of them.
Oh, you went through both of them? Okay.
Yeah.
Can we pull up the board?
Sure. Can you see it?
Yeah.
Yeah, so on my side, this one is on hold. Relay resync process on restart is in progress. And I created this new ticket to unbundle old blocks and new blocks processing. And API for module to interact with saved blocks is also in progress. So once I finish with the API, I will continue with unbundling. And then after I unbundle, we can close this one as well.
Okay, so relay resync process on restart is blocked until the unbundling is done.
Right.
Okay. And once you have the API created, does that mean that Nazar, you'll be able to like just run it from Genesis and submit whatever we have in the block store, in the data store?
Was it a question for me?
Yes.
Can you repeat?
Yeah. So so Serge is working on this API to access the block store. Once we have that API defined, are you going to implement the actual writing of the block store at Genesis, or is that something Serge will do?
Reading.
Reading and writing the transactions.
I think I will implement reading, and everything else is for Serge.
Okay, so so can we create a ticket for Nazar for read blocks?
Oh, yeah.
Do we?
I think this is
Process
just
think we
saving.
No, this is saving, but I had a separate one for reading. Yeah, this one.
Process blocks from file system. But that's for you. Doesn't Nazar have one as well?
Let's create a new one. Okay, so how should I call it?
Read blocks from file system in preparation for put.
Is this okay, Nazar?
Doesn't matter. I know what to do. It's fine.
Okay.
I'll keep it here in this column for now.
Okay. And maybe we can differentiate here a little bit between the ones that we need to do to get to this milestone, because it seems like there's some tickets that are not critical for this milestone right now that are in the not started column.
This one is still required as far as I can understand, right?
Block size limit.
Yes.
Target change act. We're going to implement that on the client side, not in the substrate side.
Yeah, we can do it on. You mean on Relayer Node.js application?
Right.
Side. Yeah.
What do you think, Nazar? Does it make more sense for that to be? I guess it should be in both. Technically, it should be enforced on Substrate, but also checked on the client before submitting. But if it's a block size, transaction block size limit. So do you mean transaction size limit or maximum transactions in a batch?
I think
No,
it's
I don't
just
think.
TX size, not TX block size.
I think initially it was yeah, transaction we receive on the pallet feeds, but for now we can just check the block size on relayer backend, and if like it exceeds the block size, then we just don't submit transaction to pallet feeds.
Okay, let's change the name of that ticket to ensure transaction size is smaller than block size. So I think it's a little bit confusing the way it's written.
Ensure transaction size is not bigger than block size.
Sure, or smaller, but yeah, that works too.
Wouldn't you get an error from the RPC endpoint if you try to submit something too big?
Mm,
Did you
we
try
can
to
try.
submit something like 5 megabytes and see what happens?
Yeah, we can try.
Yeah, there is the limit for the RPC. I can't remember the exact number, but it's probably 10 megabytes. I can't recall.
How much?
It's perhaps 10 megabytes.
10
I don't
megabytes.
remember the exact number. We can check it later.
Did you say 2 or 10?
I think 10.
I heard 2.
I heard 2. Are we talking
10?
2, Liu-Cheng?
10 or 2?
10.
10. Okay.
10.
Got it now.
Okay. What else? Implement multiple. I think this is not critical, right? Since we are going to submit single block, single transaction.
But I can implement it if necessary. It shouldn't be difficult.
Okay, it's not critical right now. So let's move that to no status.
No status, okay.
Okay.
Process block from file system. This is critical. Extend processing from Genesis to parachains. This is next step after we're done with Kusama. Add free put call to the pallet feeds. Do we still want it?
I think we need like a separate palette because it's not really a feed if you just arbitrarily put data.
Separate palette or separate call?
Separate palette, I think.
Why not separate call? We can just
because
specify...
separate call will mean that we put data into feed because it's palette feeds, but if it's not a feed, then like doesn't belong there, basically.
Wasn't the purpose of this free put so we didn't have to pay for storage at startup for the feed itself?
Yes.
So it is.
Okay. Okay, I misunderstood it, sorry.
Is that something you can implement, Nazar?
Aren't all of those free right now?
No. Currently we have like 10,000, just you know, arbitrary.
That's a weight. It's not
it's weight.
A fee.
Yeah, it's
not
weight.
A fee.
But if you specify 0, if you hard code 0 instead of 10,000, those will be free. I tried it.
Okay, but free in terms of fees?
Yes.
And now they're not free in terms of fees, right?
Yeah, so now you have to pay a fee for transaction. That's why we found accounts on start of Relayer.
I think weight is fairly critical for the block size estimation.
But we're going to
The problem-
enforce.
I probably
Sorry.
need to do some research to see if there is actually a difference between weight and fee. I think you can specify 0 fee, but still have weight so the block size is maintained, you know? Yeah, actually,
Liu-Cheng?
there is when you, I think when you check the extrinsic or something, you can actually return pays no. So the submitter of the transaction will not pay the fee, but weight system will still work. I think that is what we need. And we can have something like a special transaction which pilot feeds will recognize from a specific address that will be able to change that parameter to enable feeds, to enable fees. So I think that's what we need. Yeah, you can assign it to me. I will do some research. But like, we don't need 0 weight for that. We'll mess up the weight system in Substrate.
Okay, should I rename it? Just research on free transactions for pilot feeds?
Name it make early puts free in pilot feeds. I think we can make it like all of them free for now, and then we'll add a mechanism to enable it.
Do we need to do research? Maybe Liu-Cheng, do you have any familiarity with this? Do you know how this works?
So currently we want to make the protocol failures, right?
Yeah, the idea is that whenever we start the blockchain from Genesis, we want to back up, like let's say we're at mainnet launch, right? And we say at mainnet launch, we want to back up like Kusama, Polkadot, and Ethereum, whatever the state is, and we want to do that essentially for free. So we want to like seed the blockchain with some initial history. But we don't want to have to pay cost of storage for that. We just want it to be free. So we were thinking, like before we thought, oh, we'll have it as like pre-Genesis state, but that was complicated. So then we said, no, we're going to have Genesis, and then we're going to have like a period where there's basically free transactions in the blockchain for these put calls. So then we would upload all this data and we would just run it on like one single node, like one sort of trusted setup, or not even trusted, but at least setup of like a single node environment that it could run like really fast block time, and just upload all these transactions and just seed the data with like 10 terabytes, seed the blockchain with maybe 10 terabytes of data for all these parachains, relay chain, Ethereum, all that. And then once we said, okay, we've seeded the history, then we would do like a forkless runtime upgrade or something and say, now there's a cost of storage for new data, and then start enforcing it. But we'd have this like grace period. And then once we did that, then we would open up the network to other nodes to come in. So we're doing the first version of that right now with Kusama, where even though we have this like negligible 10,000 weight cost, that's even too much. We'd rather just make this like, and there's like a small transaction fee that's paid. We'd rather make it so there's 0 transaction fee when we upload like the first terabyte of history.
Okay, so before the mainnet like become full operational, we have a small period to seed the initial like the blockchain state onto our chain. So that is pretty simple. We have multiple ways to do that, and during that small period, we can just make the like the transaction, the like pays no, and we can also have like a special I just have a few ways to do that. So yeah, it's not hard. It's not hard.
Could you discuss a few options, or what you think is the easiest one to implement?
since we before during that small period, the chain is still closed. I believe we can think so. The chain is not open to the validators, like it's not open to the general users. So we can basically do anything, and we can allow some a small permission to set of like users to set our data, and we can simply make that extrinsic failures by indicating pays no. And after we upgrade to a full operational maintenance, we can just modify that extrinsic to a normal situation, or just we delete it.
You said pays no. Is that like a field in the extrinsic or in the?
Yeah, it's like the extrinsic result to indicate this extrinsic is needed to be paid, or the transaction fee will be refunded.
Is it something we can do in the client side, or do we have to enforce that in the runtime, in the call
in the
to the?
runtime.
In the runtime.
Okay. Okay.
We
So we just
already
need
do
to.
this for some of the extrinsics that we have that are unsigned. We just specify that no one pays for them.
Okay, so we just need to copy and paste one of the calls we have and just change the setting to pays no, and just give it like a name prefix free, and we can just call that for now. We don't even necessarily need to permission it yet.
Actually, we even don't have to copy the transaction, as long because we can upgrade our runtime.
Right.
Yeah.
So could we just make it pays no
And
by
yeah,
default right now, and then we don't even have to
yeah.
worry about funding these accounts to do these transactions?
I think you need to fund it just so you can make transaction, but you'll be refunded immediately.
So we never have to refund them or top them up.
I think we should.
So
still
you
keep some-
need some balance to send the transaction, because you have to pay the transaction fee to make that call. But once that transaction is executed successfully, you can get refunded.
Okay. Great. So so that should be a really simple change to the one that we have right now. It's just modifying one argument in the feed or in the runtime call.
Yeah.
Okay.
So we still keep it on Nazar, right?
Yeah, I'll take care of it.
Okay. So let's change the
Okay.
ticket. So what's it? Pays no?
Make all puts free.
Yeah, all puts are pays no. Cool. Okay.
Okay. What else? So this is still relevant, and this is also still relevant. Are we good on this column?
Hang on. So on in progress, so relay or resync is actually, well, that's in progress, but so is the. I'm just trying to get it, like, determine the critical path here. So unbundle old blocks and new blocks processing. So right now, okay, so the task you're working on right now is create API for module. That's for Nazar.
Right.
So that's the number one for you. Then you're going to work on unbundle old blocks and new blocks processing, and then you'll be able to do resync on restart.
Right.
And then you can do the transaction size, and then you can process blocks from the file system.
Correct.
And then once you can process from the file system, then you can extend processing from Genesis well, that's I guess that's the next step, right? Is to modify this to do parachains. And Nazar will work on reading from the file system and free puts. Okay. That's still a lot for you to do.
For me?
Yeah, feels like. I mean, it feels like that's going to take a while to get all that done.
Right.
Is there any way
But
we can?
I'm not sure we can, distribute these tasks because it all depends
Sequential.
on, yeah.
Is it not possible, like, to separate the seeding of the history from the resync and the continuous update?
It will be basically the same thing. So we just read from disk first, and then we start resync as usual.
Okay.
Yeah,
So then process blocks from file system, that should actually be just plugging it in to the loop with like a different, just a different call. So that should actually be like very easy once everything else is done.
yeah, just like different source of the stream.
Okay. And that's no longer using put multiple, right? That's just going to do individual transactions.
Yeah.
Okay.
Well, we can use multiple as well if, yeah. Okay. Later.
Yeah. Okay. Okay. Okay, well, I guess we need to get out of the meeting so that you can get back to work, or get some sleep so you can get to work tomorrow. Okay, I think we're good on your side, Serge. Unless there's anything else you have, and now we can probably transition to Leo and Nazar to go over what they're doing.
Yeah, I guess it's all on my side.
Okay. Leo, do you want to go next?
I don't know if I have many updates from yesterday. I just realized that Justin had some problems with this RPC WebSocket endpoint, and I am still not able to connect to the relayer or the Polkadot apps to this test RPC. I already have done this job before with the development RPC, so I decided that I was going to create a update actually this Terraform project we have before. This Terraform project that I use it to deploy the previous RPC node. So this is related actually to the Polkadot apps and the relayer, because I was thinking in using the same RPC. And I'm going to do this same process I do before, to have two versions of the relayer frontend. One like for right now, with a working like node, so we can use it as a demo for today or tomorrow. And another one for the testnet launch, right? So I will be working in that today to have this version for a demo relayer frontend and a testnet relayer frontend. Are you agree with that, or did you consider this too much?
Yeah, I think that's too much. I don't foresee a need for a demo. Like, the goal is to demo the real thing. That's really, like, all efforts are getting to making the real thing. Just like, here's a URL, you can go see it. Like, we don't have to give like a canned demo. So if that's additional work to maintain two of these, I think it's better just to focus on the one that we're going to have in production and get that going as quickly as possible.
Okay.
What do you think, Nazar?
It should not be too much work because it's just a copy paste in terms of Terraform. It's just copy paste and have just 2 instances of this. But
I
if
agree
you
with Jeremiah. We
think
don't probably need
it's
it.
too much, I will just do one. So I will be
Yeah, that's fine.
helping Justin with this Nginx configuration to have the WebSocket, the secure WebSocket endpoint. And yeah, I think that I can do that today. I wasn't able to do yesterday because I was in the airport and I got with no electricity. But right now I am in my sister's home. I sleep all the the night in the plane. So after the call, I will be working in that. So I let you know when I have this done in Discord. And that obviously will solve these Polkadot apps pull requests also. Shouldn't be take me too much time. I think that half an hour, something like that. Like I said, I already do that before.
Okay, so after that, we'll be able to submit the PR for Polkadot.js, and then you'll be able to deploy. We already have the relayer deployed on a CDN. It just doesn't connect to anything yet.
Yeah,
But now there will be an endpoint it can connect to.
Yeah, it's just that. The
And
deployment is done.
And the relayer backend is going to be working on a different DigitalOcean droplet.
Yeah, I think so. I prefer that.
Have you started working on that at all?
No.
Okay.
No. Now that I have this, move it to the relayer itself repository, I just have to create another virtual machine and have this running in there.
Okay. Do we have a task on the board for that? Because you really have 2 deployment tasks, right? CDN deployment at the front end, and now DO deployment at the back end.
We'll create one.
Okay.
Deployment over deployment backend over DigitalOcean.
And Nazar, you have another task as well of backing up, taking whatever you're storing locally on your machine and like putting that somewhere that's retrievable by this droplet.
Yes.
And what do you think? Sorry, I guess we're jumping ahead. Leo, do you have anything else you wanna cover or update us on?
No. I think that's the only pending things we have for today and to get this working.
Okay. Any questions for Leo from anyone? Okay. Okay, Nazar, do you want to update us on what you've been doing with the block store or what you're thinking for that?
Yeah, so I've updated it slightly and submitted pull request and merged into the new repository. The change I did on top of what I explained last week or week before that is basically I replaced creation of separate files with RocksDB. That saves a lot of space. So far I have converted or like re-downloaded from local node 60% of the blocks of Kusama history. And I estimate that the total size of the whole history will be under 4 gigabytes in this form. That is like a little bit more than 1% of what actual Kusama node stores in general. So it is pretty small. It will be not much on the subspace history.
Wait,
I think we will need.
It's 1% of what the Kusama node stores? But
Yeah, it's
I'm
like
confused.
1.1%.
So the history is 4 gigabytes, but the Kusama occupies 400 gigabytes on disk or substrate?
350. Yeah. I think it's like all transition states and other auxiliary information that it stores. Blocks themselves are very small.
Were you running it in archival mode where it was storing like transaction receipts and event receipts and everything?
Yeah, it's archival node.
Even that seems way too large.
Yeah.
100x difference?
From current size and progress, it is estimated like 1.12% of the original node size will be our archive. It'll be under 4 gigabytes. So that's what we'll need to store in Subspace, just very little.
That seems, I'm just really surprised by that number. It seems like maybe there's something wrong there. I mean, I would imagine like 10x, maybe worst case, but 100x.
Okay,
is
so
like
let's
really
say
hard to believe.
one block is 15 kilobytes, and then we have 9.7 million. And then this is in kilobytes, this is megabytes, this is in gigabytes. Yeah, it shows quite a bit more. I guess
Really, blocks would be small.
Yeah, maybe that's why. We'll see. It shows about 135 gigabytes if I take the average block size of 15 kilobytes. Yeah, we'll see. We'll see what the average block size turns out to be. But I'm at 60% right now, so pretty far.
60% in terms of block height or in terms of
Block height.
Ah, well, that explains it. Yeah, it's going to get bigger as we go. It's like the block size is increasing. So that, okay, now that makes sense. Especially once parachains become a thing, the blocks are going to get much, much bigger.
Yeah.
Okay. All right, so it's not linear.
Yeah, and I think the most productive way for everyone would be to share it using torrent. We don't need to have some server. We can download pretty fast. So I'll probably just create a snapshot of this data and share it as a torrent link. And then on the server, we'll be able to download it.
So we have to create a torrent adapter on the relayer.
No, we can just run in CLI and just pull it.
Oh, just write it to disk locally.
Yeah.
From like BitTorrent C or something. BitTorrent or whatever it's called. Okay. And can you handle that as well?
Yeah.
Yeah, you're okay. So you're working on that whole workflow.
Yeah.
Okay. Does that make sense to you, Serge, the way we just described that?
Yep.
Okay. So you're working on the API for Nazar, and then Nazar, once we have Kusama downloaded, you're going to torrent it, put that up on BitTorrent. So you're going to host that from your machine then, I guess.
It's mostly 24/7 online, so it shouldn't be a problem.
Okay. And then you're going to reconfigure the relayer to have like a CLI app that can download this. So then you'll go on relayer, run sync Kusama. It'll pull using BitTorrent, it'll pull it from your machine. And then Serge can go in and read that history, write all those blocks with the free transaction. So that's the other thing you're working on, is the free put transaction. And then all those blocks will be written from Genesis, and then it will be and then it will start catching up the backlog. Once it finishes writing from the block store, then it will start syncing the backlog from the network while caching the new blocks as they come in, making sure we don't exceed the buffer size. And then it should eventually just get synced, and then it's just going to process new blocks as it comes in. And then if it shuts down, it will resync over the history from the point that it was last shut down while processing the new blocks, and then eventually get caught up again. And then we're golden. Make sense to everybody? Okay. All right. Any questions? Cool. Does this make sense to you, Liu-Cheng? Liu-Cheng is frozen again. Okay. Okay, cool. All right, well, thanks everybody for joining us today. And we are very, very close to having this working and having Kusama backed up on our testnet. All right.